Hello there, and welcome. Have you ever stopped to think about what keeps your feet on the ground? Or, what keeps the moon hanging up there in the sky? Well, today, we're going to dive into the amazing invisible power behind all of it, gravitational forces. So, let's start with a simple question. We've all seen things fall, right? An apple from a tree, a pencil off a desk. But why do they always fall down? Why not up or sideways? It sounds simple, but that one little question is going to lead us to a huge, powerful idea in science.
So the answer to our Apple question is an invisible force. Yep, and our first mission right now is to figure out exactly what this mysterious force is.
Okay, so that invisible force has a name. It's called gravitational force, or in Arabic, الجاذبية. And just like you see here, it's the pull that yanks the apple right down to the earth. This actually leads to a famous story about the scientist Isaac Newton, who apparently got his big idea about gravity after watching an apple fall. Now, here's where things get really interesting. See, not all forces are the same. On the right, you've got your contact forces. These guys have to actually touch something to work, like friction when you rub your hands together. But gravity is special. It's over on the left, a field force. And that means it can pull on things from way across the room or even across space without ever touching them. So, here's the main takeaway. Gravitational force is the force that pulls or attracts any two objects that have mass. And here's the thing, everything has mass. You do, the Earth does, even your pen has mass. And that means all these things are pulling on each other, all the time. And remember, it's always a pull, never a push. Okay, hold on. If everything is pulling on everything else, why don't I feel my desk pulling me closer? That's a fantastic question. And the answer is that the strength of gravity isn't always the same. It can actually change. So let's take a look at how. So there are two big rules that tell us how strong gravity is. Rule number one is all about mass. Take a look at these diagrams. They show that the more mass something has, the more stuff it's made of, the stronger its gravitational pull. That's exactly why we feel the pull of our huge planet Earth, but we don't feel the pull of a tiny little pencil. And now for rule number two, distance. It's pretty straightforward. The farther away you get from an object, the weaker its gravitational pull becomes. It's kind of like listening to music, The farther you walk away from the speaker, the quieter the music gets. Gravity is just like that.
All this talk about mass brings up something really important. A lot of people use the words mass and weight like they're the same thing. But in science, nope, they're totally different. Let's break it down.
This chart makes it super clear. So mass, or al-kutla, is how much stuff is inside an object. We measure it in kilograms, and here's the key. It never, ever changes, no matter where you go in the universe. But weight, al-wazn, that's different. Weight is the measure of how hard gravity is pulling on your mass. Since it's a force, we measure it in newtons. And because gravity can change, well, so can your weight. And this picture is the perfect way to see it. Just look. In the top row, the object's mass is always 6 kilograms. On Earth, on the moon, out in deep space, it doesn't matter. The amount of stuff inside it is the same. But now look at its weight down on the bottom row. Whoa, on Earth, it's 60 newtons. But on the moon, where there's less gravity, it's only 10. Your mass is always you, but your weight, that just depends on where you are. So, we know gravity makes apples fall and gives us our weight. But that's just the beginning. Honestly, gravity is kind of the boss of the entire universe, and it has some really big jobs to do. For example, have you ever been to the beach and noticed the water level change? Well, believe it or not, that's gravity. The gravitational pull from the moon and even the sun actually pulls on all the water in Earth's oceans. That constant tugging is what makes the tides go in and out every single day. How cool is that? And what about up in space? Well, gravity is like the universe's superglue. It's the sun's massive gravity that grabs onto Earth and all the other planets and keeps them orbiting around it. And it's the Earth's gravity that keeps the moon circling around us. Without gravity, everything would just fly off in a straight line into space.
And if you want the ultimate wow moment, gravity is also the reason we have black holes. These are spots in the universe where gravity has become so powerful, so incredibly strong, that it pulls in everything around it. And its pull is so intense that nothing, not even light itself, can escape. Now that's some serious power. Wow, you're doing an amazing job. We've covered some big ideas. So what do you say we do a quick practice question just to see what you remember? Don't worry, it's just for fun. Okay, here's the question. The orbital motion of satellites depends on, is it A, electrostatic forces, B, gravitational forces, C, magnetic forces, or D, friction forces? Take a second and think about what we just talked about.
And the correct answer is B, gravitational forces. If you got that one right, awesome job. It's the very same force that keeps the moon orbiting the Earth that we use to keep all of our satellites flying in the right path. Fantastic work.
All right, let's do a super fast review of the main points. First, we learned gravity is a field force that pulls things together. Second, we found out it gets stronger with more mass and weaker with more distance. And finally, we learned that super important difference. Mass is the stuff you're made of, and it's always the same, while weight is just the pull of gravity on you, so it can change. You got this.
I mean it. Great job today. You really tackled some big ideas, and you did an awesome job with it. You should feel really good, because now you've got a great handle on gravitational forces. Okay, before you go, I want to leave you with one last little puzzle to think about. If the sun's huge gravity is always pulling on the Earth, why don't we just fall right into it and burn up? That's a good one to chew on. Keep asking those big questions, and always remember, learning is a blast. See you next time.